All right, so now we're going to talk about indoor pollution. Okay, now some of the things, there's a lot of similarities. Okay, so any kind of fuel combustion that's happening indoors could be something very primitive, pioneer like burning wood, which in a lot of places of the world, people still do that inside their homes to heat up their homes or to cook. Some places they will even burn dry dung, okay, because it is combustible. And that's, anytime you're burning fuel like that, whether it's wood or it's your furnace here in the United States, or you're burning dung in a very poor country in order to make food or heat up your tent or your hut or your house, you're releasing particulate matter into the air that you're breathing. Incomplete combustion makes carbon monoxide. You're also making those NOxes and those SOxes. So that can be very detrimental to health, to the lungs, especially for kids and the elderly, okay, people who have asthma. So those are not very good things. Also, things that we are more concerned here in the United States is building materials or furniture, okay? So asbestos are basically this compound or this structure. It's kind of fibery. It's very sturdy though, so it's used a lot in building materials. It can really get in those fibers though. When they're small and you breathe them in, they can get in your lungs. They can cause cancer. They can cause other kinds of respiratory issues. So that's a big problem, okay? And we're exposed to them like during construction, renovation, demolitions, building, when you're building something from scratch, if you're using those materials. The EPA does have some regulations for asbestos, but it is mostly regulated state by state, so it depends on the state. VOCs, so those volatile organic compounds, especially one to remember is formaldehyde. So used a lot in furniture, flooring. Is just a chemical that's used, okay? And over time, it seeps into the air slowly. You probably couldn't even smell it, but its presence is there. Sometimes you can smell it. Paint, has that strong smell. There's volatile organic compounds coming out of that as well. Some older homes that don't have PVC piping may contain lead in their pipes, okay? And of course, that can leach into the environment, could leach into the water that the people who live in that home are drinking, okay? And of course, there are natural sources of air pollution. Mold, okay? If you're breathing in mold, you could cause allergic reactions, could be detrimental for people with asthma and other things like that. Okay, radon is a big one. So radon comes from bedrock, and it is a result of uranium that is going radioactive decay. Okay, and there's radon that's naturally coming up out of the ground. But when you're outdoors, it's typically not very concerning, okay? But when you are indoors and your house is well insulated and it seeps in through a crack in your foundation, then it can actually cause lung cancer. After smoking, which is another type of indoor pollution, if you're smoking or secondhand smoke, of course, smoking is the #1 cause of lung cancer in the United States. I believe it's something like 80% of all lung cancer, perhaps, is a result of either first or secondhand smoking. But the second one, which I believe accounts for about 15% of the lung cancer in the United States, is radon exposure inside your own home. About 1 in 15 homes, I believe, in the United States. So less than 5%. No, a little bit more than 5%. So like 7.5%, I can't do the math in my head, of homes in the United States actually have noticeable sign or concentrations of radon in the home. Okay, and when you are buying a home, when you're doing the inspection, you can request a radon test, but that's typically extra. It's not mandated. But ways to mitigate that, to fix that, is to seal cracks in the foundation. Sometimes if there's just a ton of radon coming off the ground in your home, you can actually install a ventilation system in your basement to take that air and push it outside so that it decreases the concentration of radon inside the house. Okay, and of course noise pollution inside is also a problem, not just outside. Want to talk about legislation a little bit, ways to mitigate air pollution. So the Clean Air Act of 1970, which is the same year that the EPA, Environmental Protection Agency, was created here in the United States. It measures and it regulates these main ones here: ground level ozone. Remember, that's that tropospheric ozone that's bad for us. Particulate matter, 2.5 and 10 microns or less. Carbon monoxide, your SOx's and your NOx's. And it banned lead in gasoline, which was super effective. Okay, so it regulates these. It mandates certain things like catalytic converters, point source of pollutions. If you remember what a point source of pollution is, like coal plants and other industry, they have to have precipitators. Remember, electrostatic precipitators, or those scrubbers, to reduce or completely eliminate the amount of pollution that's being released into the air. Okay. Another piece of legislation that's very important is the Montreal Protocol. This was done in the late 1980s, so around the time of Ronald Reagan here in the United States. And what that agreement was to phase out the CFCs, the chlorofluorocarbons. Okay, it was a very effective agreement, unlike the Kyoto Protocol that tried to reduce greenhouse gases. This one was super effective. And one of the reasons was because there was another cheap, effective replacement already available. And those are the HFCs or the HCFCs, so hydrofluorocarbons or hydrochlorofluorocarbons, okay? So basically, they don't react with ozones. They do the same things that the CFCs do, but they don't react with ozone. Now, these are still greenhouse gases, but they're not as bad as CFCs. And the Montreal Protocol has been amended to try and phase these out as well, because they are greenhouse gases. But super effective in banning CFCs. The ozone layer, though, does recover very slowly, because the chlorine or the CFCs and the chlorine from the CFCs stays in the atmosphere for a very, very long time. So I actually checked it this week, and on the northern hemisphere, the ozone layer is going to be completely fixed in about 6 years, scientists think. So if you think from 1987 till 2026, but the ozone hole in Antarctica, which tends to be the biggest in September because that's the winter over there, is probably not going to be completely fixed until 2060 or 2070. So that's, when we're talking about a long time, we mean like a long time. Okay, so just a couple of websites I wanted to show you real quick. This here, and I will post this link to Google Classroom so you can see, is, let me refresh this so oh, there's all of China right there. Okay. It's the AQI, Air Quality Index, all over the world. Okay, so you can see actually most of our very air polluted cities in the world are in China right there. Okay, and we have several of them in India too, and other different places in the world. But the whole point of this here, one, is you can see it real time. This is real data, real time right now. Okay, but basically you can see how effective the Clean Air Act was in the United States here, and you can see too in other places like Canada and Europe that also have strong environmental regulations that was very effective in lowering just the amount of air pollution. And you can see in countries like China and India that don't have as stringent regulations, that air pollution is still pretty bad, and it's a major cause of health concern in those places. Want to show you some pictures here of So here, this is LA. The smog in LA is just terrible. But during the shutdown in 2020, see March here, right at the beginning of the shutdown, you can see just the dramatic improvement of air quality just because there weren't that many cars in the road. Okay, so that's that. Here is another example of the United States, March 2019, March 2020. So you can see there's definite decrease in air pollution, okay, in a lot of areas. And then this is the New York area, but of course here you can see Cleveland right here. This would be Detroit over here. So this is March 2015 to 2019 average. These are NOxes that are being measured. And then this was during the shutdown. Okay, so you can see everything looks better. Okay, there's still some areas that don't look as great, those very heavily populated areas. But just to compare the two pictures, I believe this would be Pittsburgh right here. You can see the difference, right, during the shutdown because, again, not as many people on the roads. And though that's all I had to show you.